and namaste everyone. This is Santosh Shrestha. I'm presenting this presentation today. Analyze the structure of small buildings of specific design. We're gonna discuss about this topic. First of all, the introduction. Small buildings design in New Zealand encompasses a range of consideration unique to the country's environment, cultural heritage, and regulatory landscape. Designer must account for New Zealand's diverse climate, which varies from subtropical in the north to temperature in the south. This variety influences the need for appropriate insulation, ventilation, and natural lighting to create comfortable indoor environments suited to each region. Sustainability and energy efficiency are key aspects of small building design in New Zealand. Incorporating passive solar design, energy efficiency window, and insulation contribute to the reduced energy consumption and improved comfort. The use of green building practices such as solar panels and natural ventilation further enhances our building's performance. Another topic is importance and relevance of small building design in New Zealand. We are discussing about the topic of housing affordability, sustainability and energy efficiency, urban density, flexibility and adaptability, compliance with building codes. Housing affordability. The New Zealand has been facing housing affordability challenges, particularly in major cities like Auckland and Wellington. Smaller buildings such as tiny house, studio apartments, and compact houses offer more affordable option for home ownership or renting. Sustainability and efficiency. Small building designs often incorporates sustainable features such as energy efficient appliance, passive solar design, and rainwater collection. This aligns with New Zealand's commitment to environment sustainability and reducing carbon emission. Another topic is like urban density. As cities grow, there is a need to increase urban density to make better use of available space and resources. Small building design can contribute to this by allowing more housing options within existing urban areas, reducing urban sprawl. And another topic is flexibility and adaptability. Small buildings can be more flexible and adaptable to different needs and lifestyle. For example, they can be used for a variety of purposes such as homes, holiday accommodation, or work spaces. And another topic is compliance with building codes. New Zealand has strict building codes that emphasize safety and sustainability. Small building can be designed to meet this code more easily than larger structures, making them a very viable option for developments and homeowners. Another topic is we are discussion on functionality, sustainability, user needs, materials, time, and cost implication impact the design processes. Functionality. Functional design prioritizes the effective use of space and resources to accommodate the intended purpose of the building. This includes considering factors such as access, layout, and flow of movement within the structure. Functional designs maximize usability and comfort, providing efficient solution to meet the specific need of the building occupants. Another topic is sustainability. Sustainability in design focuses on reducing the environmental impact of the building throughout its lifestyle. This involves energy efficient design, the use of renewable resources, and minimizing waste. In New Zealand, this may include incorporating passive solar design, efficient insulation, and water conservation measures. Sustainable design can also improve long-term operational costs and enhance occupant comfort. Another topic is user needs. Understanding user needs is fundamental to the design process. This involves engaging with the client or community to identify their specific requirements and performance. Whether designing or residential, commercial, or mixed use spaces meeting user needs ensure the building is practical and suits the occupants' lifestyle or business operations. Another topic is materials. The choice of materials can have significant implication for the building sustainability, durability, and aesthetics. Using locally sourced materials such as timber, concrete, and stone support the local economy and reduce transportation-related emissions. Additionally, selecting materials based on their performance and longevity can improve the building's overall quality and lifespan. Another topic is time implication. Time management is crucial in the design and construction process. Efficient planning and execution can lead to timely project completion and minimize disruption. This includes considering the availability of materials, skilled labor, and weather conditions. Time-saving construction methods such as modular or for fabricated building components can expedite the processes. Another topic we are discussing are cost implications. Cost consideration plays a central role in the design process. Balancing initial construction cost with time, long-term operations expenses is essential for creating value for the client. While high-quality materials and advanced technologies may increase the upfront costs, they can lead to lower maintenance and energy expenses over time. Budget constraints must be carefully managed to ensure project feasibility. Integrated design approach and integrated design approach is essential to address the complexity of functionality, sustainability, users needs, material, time, and cost implication. Collaboration effects between architects, engineer, and other specialists can result in innovative and efficient design that align with the project goals. Another topic we are discussing our determine design criteria and safety factors in assessing design loads. Design criteria: structural load types, dead loads. Permanent statics loads including the weight of the building structure such as wall, floors, and roof. These must be carefully calculated to ensure the building can support its own weight. So we have to design the small buildings like wall, floors, and roof, so building can handle their own weight. Another topic is like live loads, dynamic loads due to occupants, furniture, equipment, and other movable items. The designer must account for these varying loads to ensure structural integrity and safety. Environmental loads, nature force such as wind, snow, and earthquake in New Zealand, seismic load are of particular importance due to country's active tectonic setting. Other loads, unusual loads such as impact load, vibration, or hydrostatic pressure that might be relevant depending on specific design context. Serviceability criteria, deflection limits, allowable deflection of structural elements to prevent sagging or vibration that could impact user comfort and building performance. Crack control, monitoring the formation of cracks in concrete and masonry to maintain aesthetic quality and prevent water intrusion. Material properties, strength and elasticity, selecting materials with suitable strength and elastic properties to withstand anticipated loads. Durability, choosing materials that can endure environmental condition and minimize maintenance over time. Code compliance, building code requirements, ensuring that design adhere to New Zealand's building code for structural strength, serviceability, and safety. Local regulations complying with specific regional building standard and regulation. Another the topic we are discussing of safety factors, load factor, design safety margin. Applying a margin of safety to design loads to account for uncertainties in the calculation and variation in actual load. Factor the loads multiplying expected load by a factor for their load to increase safety and provide a buffer for unexpected events. Material factors, material resistant factors, incorporating factors of safety for materials to account for variation in quality, manufacturing, and performance. Reliability, choosing a reliable material and proven construction method to mitigate risks. We have to choose the materials very redundancy and robustness. Structural redundancy, designing buildings with multiple load paths to provide alternate routes for loads if one path fails. Robust design, creating structures that can withstand localized failures without collapsing or reducing the risk of catastrophic failure. Site conditions, geotechnical assessment, analyzing soil properties and site-specific hazards such as liquefaction risks to guide foundation design and other structural considerations. Climate and environmental condition, regional climate. The New Zealand varied climate influence design choices such as insulation, shading, and ventilation. For example, building in colder regions may require better insulation, while those in warmer area might prioritize natural cooling strategies. Regulation and code, building code compliance. New Zealand building code specific performance and safety requirements for structures design criteria must meet or exceed these standards. Material availability and property, local material availability and cost of local materials such as timber and concrete can influence design criteria. Local materials often have a smaller carbon footprint and may be more affordable. User needs and performance, functional requirements, the intended use of building, residential, commercial, drives design criteria such as space layout and accessibility of aesthetic consideration, user performance for style finishes and landscaping can set design choice, balancing visual appeal with functionality. Sustainability goals, energy efficiency, prioritizing passive design strategies, energy efficient system and renewable energy sources influence criteria selection for building orientation, window placement and insulation. Cost and budget. Construction constraint may limit the scope of design option requiring trade-offs between aesthetics, materials and features. Long-term cost, consideration of maintenance, operation and energy cost over the building life influence design decisions. Key structural elements, framing system, load bearing walls. These provide essential support for the roof and upper floors, distributing load evenly to the foundation. Column and beams, structural elements that transfer load from the roof and upper level down to the foundation. Timber framing is commonly used in New Zealand for its availability and seismic performance. Shear wall, walls designed to resist later forces such as wind or seismic activity. In small buildings, they are crucial for stability and structural integrity. Roof trusses provide support for the roof covering and transfer load to walls or column. The design may vary based on the roof shape and pitch, the foundation and structural requirements. Deep foundation, pile foundation may be necessary in areas with poor soil stability or high loads. Foundation designs, load distribution. Foundation must be distributed load evenly to avoid differential settling and potential damage. Integration and inspection, integration with superstructure, proper connection between
Dos
the
second back.
foundation and the superstructure ensures efficient load transfer and overall stability. Conclusion. In conclusion, the analysis of key structural elements, foundation and substructure requirements for small building in New Zealand emphasize the importance of comprehensive approach to ensure safety, stability, and performance. By considering the country's specific geotechnical conditions, building codes, and environmental challenges, designers and buildings that are resilient and well suited to New Zealand's unique conditions. Materials and construction methods must be carefully chosen and controlled to enhance the building strength and durability. By focusing on these key areas, architects and engineers can design small buildings in New Zealand that offer longevity, structural soundness, and peace of mind for occupants, ensuring that the building remains functional and safe throughout their lifespan. Thank you.
16 मिनट भइसक्यो
Let's take the last one. Sorry? Limitation of small buildings?
Some limitation of the small building.
In small building there is like limited option for the design, limited space for the designs, and
less privacy
in a small building there gonna be less privacy for the occupants, and small building
are small compared to big building.
yep.